Now see this question. Consider a hydrodynamically fully developed laminar flow through a circular pipe with the flow along the axis, that is z direction. In the following statement, T is the temperature of the fluid, Tw is the wall temperature, and Tm is the bulk mean temperature of the fluid. Which one of the following statement is true? And we have four options. The first option says, for a thermally fully developed flow, del T by del Z is equal to 0 always. Option B says, for constant wall temperature of the duct, del Tm by del Z is equal to constant. Option C says, Nusselt number varies linearly along the Z direction for a thermally fully developed flow. And option D says, for constant wall temperature of the duct, dTm by dz increases exponentially with the distance along Z direction, right? So these are the four options. Now, if you see this problem, see, this is the pipe, right? This is the pipe, and the pipe wall temperature is Tw. Local fluid temperature is T, and Tm is the bulk mean temperature of the fluid. It is mentioned in the problem. And for understanding the problem, what I am assuming here, Tw is greater than Tm. Tw is greater than Tm. And at the inlet of the pipe, the mean temperature, the bulk mean temperature of the fluid is Tmi. That I am assuming here. Okay. Now, if you see the option number A, that option number says is, for a thermally fully developed flow, the del T by del Z is 0. That means in the Z direction, the temperature is not changing. In the Z direction, temperature is not changing. Okay. Now, if you see this diagram at a particular r distance, let us consider a particular radial distance r. A particular radial distance r. A particular radial distance r. Now, Tw is greater than Tm, so definitely heating of the fluid occurs. What I am assuming here, Tw is greater than Tm, so definitely the heating of the fluid occurs. And if you see the temperature, if you see the local fluid temperature here and local fluid temperature here at a particular r, I am fixing the r, at a particular r, if you see the local fluid temperature here and the local fluid temperature here, that is not same. Since heating of the fluid occurs, so definitely temperature increases in the Z direction, right? Temperature increases in the Z direction, right? Bulk mean temperature, or you can say the local fluid temperature, right? Local fluid temperature also increasing in the Z direction. So that option A is the incorrect. Option A is incorrect. This is wrong. Option A is wrong. For a thermally fully developed flow, del T by del Z is not equal to 0. Okay, I hope you can understand this point. Okay, option B says, for constant wall temperature of the duct, that del Tm by del Z is equal to constant, right? Del Tm by del Z, that means Tm is the bulk mean temperature. So option number B says, in the Z direction, the del Tm by del Z, that means Tm variation with respect to Z, right? Tm variation with respect to Z is linear variation, right? Del Tm by del Z, that means this is the slope of Tm variation with respect to Z. So del Tm by del Z is constant, that means Tm variation with Z is linear, but actually the Tm variation with Z is exponential variation, right? If you see this graph, see, right, this is the variation of Tm, this is the variation of Tm. This is the variation of Tm. Tm is a function of Z, and how it's changing? It changes exponentially. Here the temperature is Tmi. Right? So this is also wrong. And if you see the variation of Tm with respect to Z, this is the variation of Tm with respect to Z. Tm minus Tw upon Tmi minus Tw is equal to e to the power minus Hpz upon m dot Cp. And if you find dTm by dz from here, it is very much clear this relation is the exponential relation. Okay, so this option is also wrong. Option number B is also wrong. This is also wrong, right? So for constant wall temperature of the duct, del Tm by del Z is equal to constant. This is wrong, right? Del Tm by del Z is exponentially varies, right? And it exponentially decreases actually. Now option number C says Nusselt number varies linearly along the Z direction for a thermally fully developed flow. So Nusselt number varies linearly. Now if you see the Nusselt number variation in the thermally developed region, in a thermally developed region the Nusselt number value is constant, right? It is not varies with respect to Z, right? So Nusselt number value is constant. So option number C is also wrong. Option number C is also wrong. This option is also wrong. Nusselt number varies linearly along the Z direction for a thermally fully developed flow. This option is also wrong. Come to the option number D. For constant wall temperature of the duct, dTm by dz increases exponentially with distance along Z direction, right? So see, in this direction, in this direction, Tm changes exponentially. That is correct. That is absolutely correct. Tm changes with respect to Z exponentially. That is absolutely correct, right? But the dTm by dz is nothing but the slope of this profile, this temperature profile. If you see here the slope, and if you see the slope here, if you find the slope, let us consider this slope is theta 1, and if you find the slope here, let us consider this slope is theta 2, and it is very much clear that theta 2 is lesser than the theta 1. That means in the Z direction, Tm increases because heating of the fluid occurs. So Tm definitely increases, and how it increases? Exponentially increases. But the dTm by dz decreases. It decreases exponentially. Okay, so option number D says for constant wall temperature of the duct, dTm by dz increases exponentially. This is wrong. Not increases. dTm by dz decreases. So option D is also wrong. Option D is also wrong. Right. So actually in this problem all the four options are wrong, and that's why that ISC is given MTA. That means marks to all. Right. So in this problem all four options are wrong. Right. So in this problem definitely, right, marks to all is given by the ISC.